time to start a journey of 40,000 years, and we're going to have to do it in 1 hour. And I am not competent with the thing.
Widget.
It's the widget. It's a widget.
So I'm under operator device. So what we're going to do, I talked about Cosmic Quest, as you can see, is to cover the whole history of astronomy, to know how we got from what we used to think, we lived on a flashish kind of an Earth, which was perched on top of 4 elephants, which are perched on top of a tortoise. Way back in the 19th century, the astronomer royal at the time presented his view of the universe on a diaposcope rather than a static PowerPoint, and maybe the audience asked him, "Please, sir, what does a tortoise stand on?" He said, "Gravely, madam, it's tortoises all the way down." Anyway, nowadays, probably the universe probably looks a bit more like this. If we could stand outside our Milky Way galaxy and look at it in the immensity of the cosmos, we're somewhere in there. That is a galaxy like our Milky Way, which contains billions of stars, everyone like the Sun, and they've got planets going around. There are probably as many planets in the galaxy as there are stars. So we are totally insignificant in the great scheme of things. How did that change happen?
Well, first of all, you have to basically make sense of the cosmos. And people made sense of the cosmos by literally looking at the stars as we do, and as hopefully we'll do tonight. But by the way, there's a comet on view near the constellation of Cassiopeia, the double-shaped one, just about visible in binoculars, called Comet Lovejoy. Anyway, what they did was join up the dots and make up stories about these constellations. They actually mapped the legends that they had in their mythologies onto the constellations they'd invented in order people could remember them for the purposes of navigation, farming, calendar making, and all kinds of things. Now let me try the widget. The widget worked. Now you all recognise that. It says Orion, so you don't have to say it. And we all think of him as being the mighty hunter with his wide shoulders, his waist, his sword just below, and at the bottom his tunic. That's how we see him in the northern hemisphere. But we have to remember that people all around the world saw constellations in a different manner. So if you go down to Australia, you see Orion upside down, quite literally, as you see the moon upside down. So how did the ancient Aboriginal peoples interpret this mighty hunter? They didn't see him as a mighty hunter. The widget's not working. Aha, the widget works. They saw him as 3 fishermen in a canoe harpooning a fish. Well, as you do. And as I said, astronomy to begin with was used not for scientific purposes, but for practical purposes. And one was actually to make sure we could understand the calendar. People noticed that the stars and the planets and the sun and the moon moved around the sky during the year. And what they tried to do was to basically encapsulate the cosmos literally in calendars of stone. Now you're all familiar with Stonehenge. We all know that the Druids go there on Midsummer's Day to watch the sun rising over hills, but they're a load of idiots, basically. And they're not Druids anyway.
Because actually archaeologists were idiots until a few years ago because they believed the same thing.
Yeah, but now what we think is that what Stonehenge is a monument to, now we're talking about something 4000 BC, was actually a monument not to the midsummer, but to the midwinter. So you stand at the heelstone, so you're standing at the heelstone on the bottom side, and you see the midwinter sun setting between the tallest of the 2 lintels. And well, doesn't that make much more sense? Suddenly, the year is turning round. Suddenly we're getting away from the darkness of winter. We're turning around to a fresh start of spring. So a lot of civilizations have built these amazing monuments to the cosmos. That's a new discovered one, Chanquillo Solar Observatory in Peru. And you see the notches on that Stegosaurus-like thing on the left-hand side. And every month, the sun rises behind one of those Stegosaurus-like promontories to mark the settings of the year. So this was a way we could commemorate the calendar. And as I said, we also use the stars for navigation as well.
Let's go to the left-hand side here. You can see that's where you stand in this building called Sunrise Observatory, which we call it Sunrise Observatory, obviously. And the sun will rise over here in the June solstice, which is the winter solstice there, and in December there, which is the summer solstice. And as I said, in between, you're going on and set behind the various towers. But of course, we're just interpreting mute stones, and it can't tell us anything. We're trying to understand them. Our first record of what people really thought about the sky come from China. Now, the Chinese invented gunpowder, and they invented paper, and, as you know, all kinds of things like that. They also invented
bureaucracy.
If we go back to 221 BC, we have records of the sky every night since then. There are 5 imperial, we call them mathematicians, we call them astronomers. They spent all night on a tower. One looked north, one looked east, one looked south, one looked west. One day on his back and looked up overhead, which I think was the best job to have, to be honest.
Oh, he fell asleep.
And they observed what was going on in the sky. And what was the reason for that? The reason wasn't what we call astronomy, it's more like astrology. For them, the heaven was a mirror of the earth. Now, the earth for the Chinese was China, nothing else actually mattered. So different parts of the sky, different star patterns corresponded to different parts of the empire. So if the astronomers reported a new star, what we now call a nova, or a broom star, what we call a comet, sweeping through one of these constellations, the emperor would know there's insurrection going on. You send out the troops, arrest the provincial governor, probably execute them as well, all because of what was happening up there in the sky. But these things were important because they were political, so they got written down. And we know, for example, these are what the Chinese star patterns look like. Here in the West, we now have 88 star patterns, like Orion, like the Great Bear, like Andromeda. China had 283 star patterns. Smaller ones, obviously, because you take the same stars and join them up in different patterns. And generally, they were different from ours. There are only 2 which correspond to ours. One is Orion, which is not in my slide. Anyone see a familiar star pattern there? Shout it out.
Plough.
Yes!
Wow,
Well done.
Now here, 7 stars in the plough. So that is one of the very few star patterns. If you take Cassiopeia, for example, which I mentioned earlier, which we see as a W shape. For the Chinese, it's 3 constellations. There's a charioteer with horses and 2 roads across the mountains. Fortunately, we can read those old records, which I can't, but other people can, and work out where these new stars and these comets appeared. And for example, in the year 1054 AD, a star appeared in what we call the constellation Taurus. The Chinese wrote about the star that appeared so bright you could see it in daylight for 23 days, and at night for 2 years before it faded away. If we look there now with a big telescope, you can see, as you use this time lapse, the remains of that exploding star. We call it the Crab Nebula now. So these Chinese observations are very useful to us, but that's not the roots of our astronomy in the West. They had a separate culture. We have to look back to Greece. The Greeks, of course, invented science around about 500 BC, and everything moved on from there. Okay, let's talk about Greek scientists and Greek astronomers. If you went for a travel agent and you booked a holiday to Greece, you'd probably expect to end up somewhere within that rectangle which I've indicated on this map. So where do the Greek astronomers live? I'll leave the other scientists out of the equation. Let's think about astronomers for a moment. The purple blobs are where the Greek astronomers lived. And apart from Aristotle, who lived in Athens for part of his life, the others were nowhere near. They're part of the Greek Empire. And astronomy as such actually began in what we now call Turkey, in the Greek colonies on the coast down here, around about 500 BC. And we had, for example, Pythagoras lived in Italy, Archimedes lived in Sicily, and along Egypt and Alexandria. But never mind, that's just an interesting point. What did they do? They said, things happen in the sky like eclipses. Let's see an eclipse of the moon in time lapse.
When's the next one?
September. That's my September this year, September 28th. But we have a book that tells you. Okay, so a lot of people said a dragon is eating up the moon, that's why it disappears. The Greeks said we're going to get away from these gods and goddesses and these things in the heavens. All this has got to be explainable by some kind of natural process. And they said it's got to be the Earth's shadow going across the moon. And they said two things. First of all, they can work out the rough size of the Earth and the moon from the shape of the shadow. But also they said, to those who said the Earth was a flat disk, a thing that's sitting on top of the elephants, then sometimes the shadow of the Earth on the moon would be a straight line if the disk is being lit up edgeways. Sometimes it wouldn't be. It's always a circle, so the Earth has got to be spherical. So the idea of the Earth as a ball in space goes back at least 400 BC. So when people say to you, when Columbus sailed across the ocean blue in 1492, people thought he was going to fall off. Actually, they didn't, because for 2,000 years, everyone had known that he wasn't going to. Let's get rid of that. But what puzzled them a lot more were things that moved through the sky. So here's some stars. Oh, it's a bright star. Oops, no, it's moving. Where's it going? It's gone down the left. Oh, no, it's not. It's going back the other way again. Hey? And that's changed its mind. Now, the sun and the moon go around the sky. They always go the same way. These things, it's going to go top right on this loop. There you see it's going down that way. They call them planetes, which means wandering stars. Because they wander, but not only do they wander, they sometimes go backwards. And they come up with a very elaborate theory, and this is a guy called Ptolemy, he lived down in Alexandria. In about 150 AD, he said, well, what happens? Obviously the Earth is in the middle, it's big and heavy and massive. Obviously the Earth is in the middle, there's a spherical Earth in the middle, the moon goes around it. We'll see at the top there where is Saturn, into the constellation of Leo, some of you might have spotted that. Here's Saturn, there's a big circle going around which carries the planet. And also go around a little circle, so sometimes when it goes around that circle, it seems to go backwards in our sky. And that theory carried on for 1,400 years after Ptolemy himself. But we think of the Greeks, perhaps, as being thinkers. They drew mathematical diagrams. They came up with Pythagoras' theorem. But actually, they were also amazing engineers. And we don't think of the Greeks as engineers. They created the world's first computer. Around about 200 BC, they created a mechanical computer with gear wheels inside it. The biggest gear was over 230 teeth, all cut out by hand, with total precision. It's called the Antikythera mechanism. I can give you a whole talk on the Antikythera mechanism, but I'm fascinated by it. It was discovered in a shipwreck in 1900, year 1900. It had been under the sea for, say, 2,000 years or so. And if you actually reconstruct what it was like inside from the fragments, there's a reconstruction. You can see all those gears, about 30 gears in there, all meshing together. There's a handle on the edge, and this is what it would have looked like. It's all inside a box, so is this lectern, no bigger than that. And you turn the handle on the side, which is there. On the front, you had a pointer going around showing the positions of the sun and the moon in the sky. We now believe it also showed the planets. That's not shown in this reconstruction, but we showed the planets too. On the back, the top dial showed the moon's phases over 19 years, and the bottom one predicts eclipses of the sun and the moon. So this was a calculator, a computer, which would allow you to predict eclipses of the sun and the moon, all made mechanically, as I say, about 200 BC. But unfortunately, the knowledge and the learning of the Greeks died out. We wrote about this in one of our books, available. And the foreword was written by Arthur C. Clarke before he very sadly died about 7 years ago. And he said that if we had actually pushed forward with the same technology the Greeks had 2,000 years ago, we would now not just be floating around on the moon and sending robots to Mars, we would be travelling to the stars if we carried on this initiative. But the Greek name died out, and the knowledge of astronomy went east, first to India and then to Persia. And a lot of advances were made, I won't talk about them now, but there was this guy called Khayyam, who, you can tell, he enjoyed his good life. He had got his flagon of wine, he's got his good book, of course, here. And he also, he enjoyed wine, women, and song. That's not beat around the bush about it.
Didn't he die in the ditch?
Not that I know of.
I think
You
it
might have done.
I think it did.
It's too much wine, women and summers.
That apparently.
Okay. What he did do, well, Harry's going to do the culture in a moment. I'll start with the science. What he did do was to measure the length of the year. This was around about 1100 AD, so about 900 years ago. So what's the length of the year? Now, the calendar that we use, the Gregorian calendar, as you know, leap year every 4 years. If it's a century year, you have to divide by 400. So the year 2000 was a leap year, which was divided by 400. 1900 wasn't a leap year. And it won't be another until the year 2400. And if you do all the sums, you average it all out. But the average length that we get in our calendar is just less than 36 and a quarter days. And I've highlighted the red figures for the minutes and seconds, so that's what's going to change in the other lines I'm going to show you. So over 900 years ago, worked out, this calendar says the year is, okay, that's it's 49 minutes, and it's a bit shorter, 3 seconds. What's the real value? Get a modern astronomer to actually measure now, with modern knowledge, the length of the year. And it's shorter than either of this, 48 minutes and 46 seconds. But you can see that Omar Khayyam's calendar from 900 years ago is more accurate than our calendar that we actually go by today.
And he was an amazing character. I mean, apart from the wine, women, and song, he was an amazing poet. And my mother used to keep a book of his poetry by her bed. And one of the poems I love goes like this. Awake, capital letters, for morning and bowl of night has flung the stone that puts the stars to flight. And lo, the hunter of the east has caught the Sultan's turret in a noose of light. Dreaming when dawn's left hand was in the sky, I heard a voice within the tavern cry, awake, my little ones, and fill the cup before life's liquor in its cup be dry. Classic piece of Omar Khayyam. And after Omar Khayyam, the teaching from the Persians gradually spilt over Europe, partly because of the Silk Route and also because of the Crusades. And it spread to Europe, and then literally a revolution emerged. It would, if I could get the word into it. You would, good the word.
Maybe because I'm lecturing.
Oh, well done. It reached Poland in the 16th century, and in particular to a Polish administrator of a cathedral in Wrocław called Nicholas Copernicus. And he picked up on the fact that the Greek teachings had gone literally via the Persians and finally had ended up in Europe. So how should he interpret them? Well, Copernicus was a fascinating figure. There he is. That's actually a self-portrait of himself. He's a very, very gifted painter indeed. And we know it's him, so I'll come back to that in a moment. He was fascinated by astronomy. On the right is the cathedral that he was the administrator of. In the middle is the tower that he used to make astronomical observations because he was fascinated by astronomy. And he was getting suspicious about the Greek teachings, and in particular of Ptolemy's observations of planets going around of wheels within wheels. But while we have our portrait of Copernicus on the screen, people wanted to know what he really looked like and where he was buried. And they actually looked inside the cathedral for a tomb. And there's this terrible orgy of literally unearthing astronomers that carried on in the 16th, 17th, 18th centuries. And they found this tomb, and they found a body, and forensic scientists reconstructed his skull. Take a look at this. Not bad. That's him. So, what did he do? Well, he came up with a completely different theory about what the solar system was all about. There's your Ptolemy's Earth-centered system, the Earth in the middle, and that's Mars going around in its little circle, going backwards and forwards across the sky, as you see. But Copernicus reasoned, I don't believe this. I believe that the Sun is so much of a more dominant body than the Earth. Surely it's at the centre of a system of planets. And it would be so much more simple to describe the behaviour of the planets if we put the Sun in the centre of the solar system. So that's Ptolemy. Here's Copernicus. There's the Sun in the centre, Earth going around. Earth going around in a smaller orbit, so it's circling the Sun more quickly than Mars, which is further out. And it makes sense, because as the Earth overtakes Mars, as you overtake a car on the motorway, Mars appears to lag behind. So that was Copernicus' sun-centred planetary system. And, well, he didn't believe it himself. In fact, he published his book, which was called De Revolution. I never can say you can't say it either.
Revolutionibus.
That's it, yeah. Literally, on his deathbed in 1543, he was caused to publish it by a gay student of his called Rheticus, who was convinced that Copernicus was right. But was Copernicus right? I mean, this was an amazing revolution in astronomy. It overturned all the beliefs people had had for 1,500 years. So how do you prove it? The answer is with measurements. So we turn to the Great Dane, Tycho Brahe, who was basically he was in charge of an amazing castle called Uraniborg on an island called Breg. He was eccentric, to say the least. If you look at his nose, can you see it's slightly skewed?
No way to get having to do this, do I? You get one of those.
He had a duel with a fellow student at university as to who was the best mathematician. So they challenged each other to a duel with swords, and they cut off Tycho's nose. And he said he replaced it because he was an aristocrat with one of gold. But they exhumed his body as well, and it turned out to be made of bronze. So that's a bit sad. He also drank a lot, and he also had pet elk. And he fed the elk so much beer, it fell downstairs and it died. But he was the most fantastic measurer of the cosmos. This was before the era of the telescope. He didn't believe in Copernicus' theory, but he was actually aided by somebody else.
What Tycho had to do was a new king came to the throne, and looking through the accounts of the country of Denmark, discovered that Tycho had been allocated 1% on the gross domestic product of Denmark. That's the roughly the same portion that NASA gets of America's budget these days. So imagine being a single scientist these days having 1% on the country's wealth to spend on whatever you like. Anyway, the new king threw him out, and he moved to Prague, where he became the imperial mathematician. And there he met up with a German mathematician by the name of Johannes Kepler. Absolute chalk and cheese when it comes to these people. Tycho was a big, blustering aristocrat. Aristocrat. Kepler was very introverted and nervous, and he was a total hypochondriac. His writings are full of the boils that he had on his bottom, but I really get there. But he was fascinated by science, the idea that of forces. And he said, if things go around the sun, because he believed in Copernicus that things go around the sun must have a force which makes the planet go around. And he was inspired. Yeah, here, let's hear it for all this revolution in astronomy. We'll be talking about Poland, we'll be talking about Denmark, we'll talk about Prague. Was inspired by an Englishman called William Gilbert. who lived at the same time as Kepler, and he did experiments on static electricity. Remember at school, you rub a rod and you can pick up feathers, like that he's doing now, or small pieces of paper, and with magnetism. And if you look carefully, you may recognise the lady on the left. That's good Queen Bess, Queen Elizabeth I. And Gilbert was actually the physician, the personal physician to Queen Elizabeth I. That's why he's really interested in science. So Kepler said he thought it was magnetism. Obviously we know now it's not magnetism, but it has a force that makes the planets go around. So he really was a first astrophysicist using physics to apply to the heavens. But while he's trying to work all this stuff out, he had a problem on his hand. His mother was arrested as a witch. This is Kepler's mother, Katrina, being shown the instruments of torture by the official torturer. She'd been dabbing in herbal medicines, and people said she'd poisoned her neighbours. So anyway, obviously that's a bad situation to be in. And Kepler, the introverted mathematician, while he was working out the sums, defended his mother in court and got her off the charge. Meanwhile, he also worked out how the planets move. They go around the sun, as Copernicus said, but they don't go in circles, they go in long shapes called ellipses. And he got there by saying a circle doesn't work, and eventually he said to himself, suppose I squeeze it. And he wrote down, suppose I take the circle and I squeeze it like a German sausage. And that's how God left for orbits. And the key thing is when the planet is furthest away, it goes slowest, when it comes closest, it goes fastest, it slows down. And so that is the way in which the planets go around the sun. But really that's as far as you could get without the telescope. And while Kepler was still alive, this happened in Holland. So we're zipping around Europe quite a lot at the moment. An optician called Hans Lippershey, he's also signed his name Lippershey. It's a bit like Shakespeare, he signed his name different ways. We're going to call him Lippershey. Discovered he had two lenses, and you had one behind the other, you can make distant objects appear closer. There's a rumour it was actually kids on the street who did it first. Whatever, he applied for a patent for what we now call the telescope in the year 1608. And it became very popular all over Europe. There was a guy in Venice who got to hear about it. His name was Galileo. So Galileo didn't invent the telescope, and the next popular belief he didn't. He heard about it. He refused to buy one, actually. He said, I'm not going to buy one, I'm going to make one myself. So he did make one. And what he did, first of all, he didn't look at the sky. He went to the Doge of Venice and said, Sire, with this device I can see enemy ships approaching Venice long before your traditional lookouts. And he could, he proved it, and then he was given a big pension. But in the end he went back to Florence, where he'd come from. And if you're in Florence, there are lots of things to do. If you're Uffizi, David, everything like that you've got to do, the Duomo, everything. Do take a chance next time you're in Florence to visit the Museum for the History of Science. It's got some of Galileo's original telescopes. It also has this rather strange thing. So it's in a glass embroidered beaker, and that thing in the middle, what's that strange, wizen-looking thing, do you think?
Think about exhumation.
Is it a reliquary?
It is, yes, it is, as it were, of Galileo. This is Galileo's finger. Oh, well, one of his fingers, obviously had 10 fingers. This is one of them. What happened was that, as you know, Galileo fell out with the church, and we're not going to go into that whole debate tonight, because you know about that. He fell out with the church, he's buried in a simple grave, with his daughter actually. She priestessed him. So he was there for a century. Then afterwards, he became famous and great. And they decided to rebury him in a very ornate tomb in the church of Santa Croce in Venice, as you can see. So there's stuff in the France, I think, as you can see to this day. But in between digging him up and reburying him, people grabbed bits of his anatomy. So he lost 3 fingers, he lost a tooth, and he lost a vertebra, all of which went off to various collectors. And the fingers eventually turned up, we've lost all the other bits of him. Never mind. We obviously got his main body, which is buried. So what did he do? He looked at the sky through his telescope, because he believed in the theory of Copernicus as well. And one of the things that people said is that, okay, if the sun is stationary and the Earth is moving, and the moon goes around the Earth, no doubt the moon goes around the Earth. So why doesn't the moon get left behind if the Earth is moving? then the moon ought to get left behind. Galileo looked at the giant planet Jupiter on the left, so his own drawings. The round thing was Jupiter on successive nights. He saw the stars either side which moved with the planet. They were not stars, they clearly were moons going around Jupiter. So Galileo said, if Jupiter can carry its moons with it for some unknown force, they didn't know about gravity, unknown force, then the Earth can take its moon with it. Very strong plank in the defense of the Copernican theory. When you look at Saturn, you couldn't tell. One time it looks it's got ears on it. The other time it looks as if it's like a toby jug with handles on it. You couldn't work that out. And he drew a really nice map of the moon, as you can see. But he was not the first.
No.
So he did invent the telescope, but he wasn't the first to turn the telescope to the sky either.
And we believe the first person to turn a telescope to the sky was a Brit, Thomas Harriot. Now, that picture of Thomas Harriot, we have tried in all our lives to get a real picture of Thomas Harriot. That's the best we can come up with. We don't think it's him.
He would look a bit like that.
He would have looked a bit like him. He would have had a little beard and things like that. But he actually did a sketch of the moon, as you can see on the right, before Galileo did. So we owe, basically, I think, our sort of use of the telescope to the British, which is absolutely wonderful. So there is Thomas Harriot's map, and we'll stay in Britain for the next bit of our story. Now that Kepler had worked out that planets move around the sun in ellipses, what was the force that was causing them to move around the sun? And this is a genuine scientific story. It's not apocryphal. There was a man called Isaac Newton who was a student at Cambridge, absolutely brilliant, but very, very academic. He spent his time just poring over papers and things like that. He failed to eat. As a result, he'd leave his dinner on the floor and his cat became the biggest cat in Cambridge as a result. But when the plague came to London in 1666 and was threatening to spread to Cambridge, he was moved back to where he lived in the manor of Woolsthorpe in Lincolnshire. And when he was out contemplating academia in his garden, he actually did literally see an apple fall to the ground from an apple tree. And we know, we've seen the apple tree, it's more or less collapsed, but you can actually date it by dendrochronology and work out it was indeed the apple tree from which Newton saw the apple fall. And he reasoned there must be a force that's pulling the apple to the ground and the earth to the apple. And he came up with, let's say, a theory of some gravity. And if you ask us to explain gravity to anybody today, I'd say forget it, because we actually don't know. Nobody knows what causes the force of gravity. We can understand electricity, we can understand the forces that go on inside the atom. Oh, you talk to various scientists, say, oh, it's caused by gravitons. What? Nobody's discovered a graviton yet. So, anyway, he said basically, this force acts in a way that the further away you are from an object, it's an inverse square law, where if you're twice as far away, the force is 4 times as weak. And he applied his calculations to the cosmos, and he was absolutely right, except he was a reclusive, and he refused to publish. So, enter Edmund Halley, who was one of his best mates at the Royal Society, and we all know Edmund Halley is the person who predicted Halley's Comet. How many of you saw it? Not many of you. Yeah. Well, 2061 is the next date to wait for. And what is it, 2134 after that? Yeah, something like that. Anyway, don't hang about. That was the view back last time in 1985-86. He didn't actually discover it. He saw it on his honeymoon in Islington would you believe?
As you do.
As you do. I don't know why anyone would want to criticise me.
This isn't here.
Sorry. But he predicted it would come back after his death in 1758, and he predicted that by knowing Newton's laws of gravity. And he said to Newton, you must publish your ideas because these are fundamental to the laws of the universe. And he finally got Newton to publish his laws of gravity in a volume called Principia. And I've seen an original copy of it, and it makes you feel, it makes goosebumps. Everybody associates him with the comet. In fact, he only spent about 3% of his life looking at comets. He was an amazing polymath. It was said he was probably a spy. He could swear like a sea captain. And one thing you probably don't know about Harry, and the next one, he invented the diving bell, as you do. So there you are. That's what Harry was up to. Anyway, the adoption of Principia and the idea of gravity absolutely gripped the whole world of astronomy. Now we're talking about the late 17th century. And for the next century, all astronomers were trying to prove Newton right or Newton wrong, except for two people. Two of my absolute heroes in astronomy. These are William and Caroline Herschel. And they were brother and sister, both musicians. He was head of the Octagon Chapel in Bath. His sister was a singer. He was passionate about astronomy, built enormous telescopes. Caroline would help him. She, in her own right, discovered 8 comets. And they weren't interested in proving Newton right or wrong. They were much more interested in surveying the cosmos, actually looking at the layout of stars and working out what the structure of all the stars out there was. And one night in 1781, Harry was out in his back garden with a telescope of his own making, with a 6-inch mirror, of which many of you will have telescopes the same size. And he saw, and I quote, a small green or nebulous object. And a friend of him came by, and he happened to be the son of basically the head of the Royal Society. And they looked at the object a couple of days later, and Herschel said, "Oh, I think it's a comet." And his colleague was not quite so certain. And he got in contact with his dad at the Royal Society, and they scrutinised the data, and they discovered it was moving far too slowly. And what Herschel had done was to discover the first new planet since the whole of history. It was Uranus. And because Herschel was, as it were, new to Britain and very, very excited to be accepted by the British community as a musician and an astronomer, he wanted to call the planet after the king, who was George III. Now, if that had been the case, we would have Mercury, Venus, Earth, Mars, Jupiter, Saturn, George, Neptune. Fortunately, he's sensible road, and the Germans said, no, it's got to be called after something mythological, so it got to be called Uranus. And anyway, this led to another revolution in astronomy. The king was so impressed by Herschel's discovery, he invited Herschel to come to Windsor with his sister to build great big telescopes to show off to visiting dignitaries. And that was the biggest one he built. It was called the 40-foot, and you could see the remains of that at Greenwich. And with that, he conducted his surveys of the sky. And he was mapping the stars rather than looking into gravitation. And he mapped the stars and made this fantastic map of what we now know to be our galaxy, our Milky Way galaxy, our own star city. It's an amazing map. And when you think we're talking about the early 1800s. It was phenomenal for that time. Meanwhile, he did actually carry on with his music. If I can get my Richard to work. And there we are. It's rumoured that Haydn, who was conducting on the right, looked through the 40-foot telescope and was so amazed by the view of the cosmos, he was actually inspired to write his oratorio, the creation. And I believe, as we pointed out, that that person just below Haydn's bow is Herschel himself playing in a string quartet. And anyway, this construction of huge telescopes spread further afield. It spread to Ireland, and that was the biggest telescope in existence in the 1870s. We're moving on a century now, with a mirror 6 feet across. The telescopes in those days, they were not using lenses like Galileo, they were using mirrors to collect the light. It was known as the Leviathan of Parsonstown, and you can see from the figures standing there that it is huge, it is absolutely vast. And what the Earl of Ross did was to look at fuzzy objects in the sky. He went further beyond the stars. He didn't know where they were, but he did drawings of them. This was before the age of photography. And he found objects like this, very strange spiral nebulae, as he called them then. And nobody actually knew what they were.
I want to slightly create a story here. So we now know there's our galaxies, like our own Milky Way. We're living somewhere first half the way out, if that were our galaxies. What people like Earl of Ross were doing was establishing the geography of the universe, but no one could actually tell at that time what the stars were made of. If you go back to the 1830s, just back very slightly, a famous French philosopher, a positivist philosopher called Auguste Comte, said, as you can see, on the subject of stars, we shall never be able to tell by any means, we'll never be able by any means to study their chemical composition. In other words, what atoms are they made of? Or actually, are they made of atoms at all? That would be made something totally different from what we have on the Earth. Well, it's no good idea to stick your neck out, is it? Because already there's a revolution underway which will show that Comte was wrong, and we can work out the universe is made of. It was thanks initially to a German called Fraunhofer. Now, he wasn't an astronomer, he actually wasn't even a scientist. He made glass. Glass is very important because you make telescope lenses, and he made the best telescope lenses of his day, and he also made prisms. Triangular lumps of glass that you can use to break up light into a spectrum. So there is the spectrum of the sun's light, a rainbow of colours. The Fraunhofer found, when he, with his exceptionally good glass that he made, it had dark lines going across it. He thought, that's no good, there's something wrong with my prism here. So he made a different prism, and they all came up the same lines, and at the end of the day he said these have to be down to the light from the sun. It was a pattern of dark lines, and then later he found dark lines, similar but not identical, in the light from other stars as well. What did it mean? In the 1850s, so a bit after our friend Comte, 2 German scientists, Robert Bunsen, remember your Bunsen burner from school? Robert Bunsen was the man who invented it. He was a chemist, and his friend Gustav
Kirchhoff.
Gustav Kirchhoff, who was a physicist, discovered that if you took elements in the lab and you heated them up, they glowed with different colours. So sodium, for example, would give lines in the yellow part of the spectrum there. If you heated hydrogen, you get a line in the red, but also a line in the blue-green, and another one in the violet, which is off the edge there. And they could match the lines in the lab with the lines from the sun, and then say, these are fingerprints. We can look at the fingerprints of these elements in the sun. So you know there's sodium, you know there's hydrogen, some of the lines down here are due to iron, some of them are due to magnesium, they can all be matched up. And one of the pioneers, Nick was saying earlier on, was the lecturer here, Norman Lockyer. And he actually looked in detail, you can't see it here, but you can see 2 lines there in the yellow part, That is due to just to sodium. If you look in detail, there's a third line there. Lockyer said in the late 19th century, there's no chemical element on Earth which matches that line in the sun. It must come from a new element. And because the Greek name for the sun was Helios, he called that element helium. And helium was discovered by Norman Lockyer in the sun before it was actually ever discovered by chemists on the Earth. A little bit of a digression there, but since Norman Lockyer was an amazing guy, he also drew up the rules of golf. Anyway, I leave that aside. The universe. So how much was in the universe? You might think, well, you've got sodium, you've got iron, you've got magnesium, everything's going to be like the Earth. Lots of heavy stuff, not very much hydrogen or oxygen. But that's wrong. The person who showed you it was wrong. So that's called, well, she's born Cecilia Payne in the county of Buckinghamshire. Not very far from where Heather and myself actually are now, in a little town called Wendover. She went to Cambridge. She couldn't take a degree. It was just before the 1920s here. They didn't award degrees to women at Cambridge until 1948. So she went to America, she studied at Harvard, she wrote a PhD. It's been judged by everyone who's looked at it as the best PhD ever done at Harvard. And what she did was to look at these lines and say, let's try to work out how much of the different elements there are. Not what's there, but how much. Complicated stuff. And she worked out that hydrogen was overwhelmingly the most important element. Over 90% of the sun and the other stars is made of hydrogen. Now, her supervisor scoffed at her. Nobody believed her until a few years later her supervisor came up with the same answer. And because he was senior, because he was male, he published it under his name. And most people associate that discovery with Russell rather than with Penn-Koposchkin. But so anyway, one of our unsung heroes, Cecilia Penn-Koposchkin. But where do these elements come from? For example, there's hydrogen in this file on the left. Here's carbon in a lump of coal. Here's gold in your ring. We now believe, we know, that when the universe started, there's only hydrogen and helium. So how do we get from there? Things like carbon, which make up our bodies, or iron. And in the mid-20th century, the 1950s, people realized they were made inside stars. So if you think about the old alchemist dream of changing one element to another, there are alchemists in the universe called stars, and this is our sun, which goes up. And the people who worked it out in 1957, so this whole work was done by a group of 4 people, and one mammoth people worked in the 1950s. Left to right, Margaret Burbidge, who was director of the Royal Observatory at Greenwich, well, Greenwich Observatory, I should say. Geoffrey Burbidge, her husband, Willie Fowler. He was an American physicist who worked in the lab with the atoms, actually in the lab, while the others were astronomers looking at the universe, and Fred Hoyle. And this is on Willie's 60th birthday, and he was a great fan of steam trains, so he's been given a working model of a steam locomotive for his birthday. And so these guys worked out how everything was made, one of the most important pieces of science in the last century. But if anyone's ever heard of these people, they've probably heard of Fred Hoyle for all the wrong reasons, because he came up with a theory of the universe which wasn't right.
Fred was a maverick, and they don't make astronomers like Fred anymore. I've interviewed him a couple of times, and sadly he died about 10 years ago. But now astronomy tends to be conducted by committees and by consensus and everything. Fred would come up with all these wild theories like life arrived on the universe in comets, in cosmic eggs. And he had a theory with this crowd that the universe had no beginning at all. It was always in a state of what was called steady state, which you might have heard of. That it never started. Its creation was topped up by one atom of hydrogen every million years, and just carried on going and going and going. So was Fred right? Was the steady state right? I remember when I was being interviewed for an interview at the Royal Observatory at Greenwich, somebody said to me, do you believe in the steady state or the Big Bang, which I'm coming on to now. Big Bang, by the way, is a phrase coined by Fred Hoyle in 1948 as being derogatory. I'm amazed at my interview panel. I said, you must be idiots. Of course it wasn't all in a steady state, it's all been proved wrong. And the reason for that is this man. Edwin Hubble, and that's him with his cat. Copernicus And he discovered in the, but it wasn't quite him, it was a number of others, but we won't go into all of that. Weston Slifer and various other people too. Discovered that, remember the image we showed you of the Earl of Ross's spiral nebula? We now know that these are other galaxies other than the Milky Way. And with the exception of very, very few galaxies, apart from the Andromeda galaxy, which you can see in the autumn, all the galaxies are actually moving away from our own. The further the galaxy, the faster is the acceleration. And the inevitable conclusion is, if you wind back the VHS, they all come together about 14 billion years ago, 13.8 to be exact. And that implies the universe had a finite beginning in a very, very hot orgy of activity, which, thanks to Fred, we now call the Big Bang. I do wish he was still with us. I really do.
He'll be 100 only this year.
He would have been 100. Yeah, I know. He was 1915 years old. Anyway, so we now know that the universe, if you backtrack the motion, was born in this really hot inferno of activity. We don't know why it happened. We don't know how it happened. We don't know what happened before it happened. We don't even know if there was time before it happened. But we now know that it must have happened. And the guys who discovered the evidence weren't actually scientists, they were both engineers using a telescope in Holden, New Jersey, a big horn antenna called Arno Penzias and Bob Wilson. Penzias on the left and Bob Wilson on the right. And they were looking for radiation around our Milky Way galaxy. And he couldn't understand why there was a permanent hiss in their antenna. And they thought, there's something wrong with our equipment. And they thought, it's because there are pigeons nesting in it. So they thought, what do we do? So they tried to get rid of the pigeons. And the pigeons were unfortunately homing pigeons. And so they came back. And they shooed them away again. And they came back for a third time. And I actually asked Arno Penzias, what did they do next? He said, well, Heather, we deterred them by decisive means. I said, what do you mean by that, Arno? We shot them at close range. He said, I'm rather ashamed of that. Anyway, the hiss still didn't go away. And it was uniform from all over the sky. And it turned out, in a phone call to colleagues at the University of Princeton a few days later, it turned out that colleagues were actually working on an idea of, shouldn't there be some remnant radiation after the Big Bang that was spread out after the universe has been expanding for 14 billion years? And it was Jim Peebles, wasn't it?
Bob Dickey.
Bob Dickey. Jim Peebles was called. Anyway, Bob Dickey came to them and he looked at their data and he said, gee guys, you scooped us. And they have actually picked up what we call is the afterglow of creation. Everybody tells you that space is at 0 degrees. It's not. It's at 3.7 degrees above absolute zero. It isn't quite cold yet. So what happened next? What happened after the Big Bang? Well, we need specialist satellites to map what happened to the early universe. And this is an image from WMAP, which is a satellite that looks at the whole universe in the X-rays it emits. And what you're looking at there is the curdling of matter, which is to make itself into the first galaxies, like our Milky Way. So that's the beginnings of our universe. And now we know that the universe itself began in a Big Bang. It was a violent place. And I think when both of us were being brought up on astronomy, the evidence for a Big Bang wasn't quite decisive. We were still feeling that it could be a steady state. We all thought the universe then was quite a calm, ordered place, nice, pretty stars, nice, ordered planets. Nothing like we had suspected was going to happen. We now know we live in a violent universe. And this goes back to the 1940s. Here is one of our great unsung heroes. He would have been 100 years old this year, Stanley. He was a school teacher. During the last war, they put very young men into high positions in terms of our British defence systems. And Stanley was in charge of radar at Morley. And one day, the radar operators noticed that the radar which could intercept German planes were being blocked by something, and thought, the Germans have actually made a secret weapon that's blocking our radars. And Stanley thought, no, it's got a periodicity around that of the rising and setting of the sun. So he got onto the Royal Observatory Greenwich, and they said, yes, there's a really great sunspot on the sun, and it's spewing out electric particles, and that those radio waves are coming out, and they're blocking your radar signals. So that was the discovery of radio waves coming from space. Up until then, basically, there had been a discovery of radio waves in America in 1931, but it had never been followed up. Stanley did follow it up, and it led to the whole birth of radio astronomy, a totally new window on the sky. And if you imagine you're playing a musical instrument, and the middle on a musical instrument, let's say it's a piano, the middle chord is a C, that stands for light. When you play the bass chords, you're playing the radio waves. When you play the high chords, you're playing the X-rays and gamma rays. Suddenly we have a whole new window on the universe, or new windows on the universe. Stanley's particular discovery led to Bernard Lovell pinching his discovery and leading to the making of Jordan Banks. I'm not knocking Bernard Lovell all that much, but I mean, that making the Lovell telescope, which is 250 feet across, was an incredible achievement for 1957, absolutely remarkable. But he did pinch his ideas from Stanley. But that was the beginning of looking at objects in the universe that were violent and exploding and things like that. And it also led to the launchings of satellites above the Earth, like this X-ray satellite, or Hurry, which looked at radiations that couldn't actually come down through the atmosphere, thank God. You wouldn't like to be pounded by X-rays every day, I can tell you. But that again led to discoveries of objects we would never have known about, like quasars, pulsars, black holes, and things giving out prodigious amounts of energy. And we think of black holes, for example, as some of the most violent objects in our universe, and we think of them as being a modern discovery. Actually, they were first predicted by a reverend called John Mitchell back in 1783 in Thornhill in Yorkshire. And he got onto one of his mates in the Royal Society, as they all do, and said, I've come up with an idea. I think there could be stars out there that are so big that they, basically, the gravity won't allow energy to escape. Well, he was very, very close, and that paper was presented to the Royal Society. In actual fact, the truth is this, and this is actually an artist's impression, I hasten to add. Black holes are actually made of objects that are so collapsed that their gravity is so intense that basically light can't escape, travels at 300,000 kilometers per second, but the gravity is so intense that it holds the light in, so they're black. And it's a hole because nothing can travel faster than the speed of light. And there you see a black hole, which is that one is the remains in the Alsace impression of a star which has exploded, its core has collapsed, and you see around it, the reason you actually see the black hole, it attracts matter into it, which surrounds it in a halo. So that is your typical black hole. We think there are literally billions of black holes in our galaxy. That's how it all happens. The black hole is on the right, and you see it surrounded by its disk, which
It's in there, it's a bit too small to see.
is literally, yeah. Yes, they are very, very small. And this one is actually literally sucking matter off its large companion star. So you actually see the altercation. It's rather like seeing a black cat and a white cat in a coal cellar at night. And you don't see the black cat, but you see the poor white cat being pulled around by the gravity of the black hole. But Nigel has an even bigger black hole for you.
That's just the beginning. When I was at Cambridge, I was working on objects called quasars and radio galaxies. This is an example. This is a picture taken with one of the biggest telescopes in the world, and most of these blobs are just stars near to us. The thing fuzzy in there, the galaxy, much bigger than the Milky Way, and it's hundreds of millions of light years away, very, very distant. But with an ordinary telescope, you can't see much. Now, if you point your radio telescope at it, like Joggle Bank or one of these others around the world that we had at Cambridge, it's part of the sky is absolutely intensely blazing with radio waves. Where are those radio waves coming from? But what I want to imagine is that you could retune your eyes, as I talked about different radiations being like notes on a keyboard. Imagine you could see radio waves coming at you. You looked at exactly the same part of the sky, and we'll cross-fade now. We'll fade out the view with an ordinary telescope. And imagine you've got your radio goggles on, so you can see this with a radio telescope. Now, all the stars are gone, because they're not part of the radio emissions. That is the object in the middle where the galaxy was. And way out in space, far beyond the galaxy itself, you have these big clouds of energy, which have been pumped out. You can see there's what we call a jet or beam of energy, pure energy, rushing out into space for 100,000 light years either side of that galaxy. So what's going on in the middle? Unfortunately, I can't show you in detail, but I will show you an artist's impression. Yet again, if you could magnify that millions of times, what we see in the middle would be, again, a black hole surrounded by torn up stars. But this one is not just a few times heavier than the Sun, like one Heather showed you. This one is 1 billion times heavier than the Sun, 1,000 million times heavier than the Sun. So it could be like 1,000 million stars that collapse into there. And as the stuff swirls around, it sends out beams way out into space. But just to finish our talk, not everything happens at the edges of the universe. Let's get back and talk about planets, things nearer to home. Again, we can't talk about all the exciting discoveries, for example, coming from Mars, in the Curiosity rover. I will just pick out one picture from our solar system, which is my favourite. This is the planet Saturn. Not as you see it from the Earth. This is taken by the Cassini spacecraft, which is orbiting around Saturn, and it's taken this picture looking towards the Sun. The Sun is behind Saturn, so it's blocked out, and you can see the dust. And that's like when you drive towards the Sun in your car and you've got dust on your windscreen. I'm sure you don't. I have lots of dust on my windscreen. And you see the dust lit up when the sun shines directly at you. So Saturn's got its famous rings, as you can see. It's also surrounded by loads and loads of dust. The most interesting of all, if you look just up there, inside that ring. It's a little speck just inside that ring. That's planet Earth. That's where we are, seen from Saturn. This is all a bit in perspective, isn't it? Anyway, so that's just our solar system, but in fact that's not everything we've discovered about planets.
We now know that there are at least 2,000, probably more, other solar systems out there. In fact, only yesterday we got news of a star being surrounded by 5 Earth-like planets. Yeah. These stars have been discovered about 10 years ago. The first discoverers were Nigel and Didier Queloz, and the most successful guy has been Jeff Marcy. And they're discovered by basically two means. One is you use a big telescope to look at a star and to look at how gravity makes it wobble as a result of the planets going around it. And then you can work out the masses of those particular planets. and their positions in their solar system. And there's another way you can do it. There is a satellite up there called Kepler, which has been hugely successful, which is looking at stars which change in brightness as a tiny planet actually goes in front of the star and the star's brightness goes down. So 2,000 of them, and many, many of them are like Earths. And this is very exciting because it leads us to, oh, that's probably one of the most Earth-like planets, artist's impression, I hasten to add. But it brings us to the whole fascinating question, which I think is one of the leading questions of astronomy today, and now right up to date. Is there life out there? Is there intelligent life out there? I think Nigel and I would be very prepared to admit we believe there is bacterial life on Mars. We've done many interviews and are fairly convinced by that. But we're talking about little green slime rather than little green men. But could there be intelligent life out there? Well, that's our friend Frank Drake, who is the person who, back in the 1950s, first addressed the question with his radio telescope and said, hey, if we broadcast to guys on Earth, might the guys out in space be broadcasting to us with their radio telescopes? And he did something very unorthodox at the time. He got told off about it. You weren't allowed to use your radio telescope to tune into aliens, but he did. And he got an amazing signal from the Pleiades one night. And he thought, oh wow, I found it. Then he put his radio telescope to another way, placed in the sky, and the signal was still there. So almost certainly it was military radar that was coming from all over the sky. This was during the Cold War. But now the people who are involved in SETI, which is the search for extraterrestrial intelligence, are using an amazing array of telescopes. There are now 40 of them in California. It's going to grow to 420 to tune into signals from alien life. Oh, and to do routine radio astronomy as well. And by the way, if you want to get involved in SETI, and it's mentioned in one of our books, sorry, there is a website called SETI at Home, where you can tune into signals that are being received by the Arecibo radio telescope in Puerto Rico to see if you can pick up your own SETI signal. Well, people have been tuning in for 60 years and we haven't found anything yet. Could it be that ET is strongly silent? Or could it be that basically our techniques are so primitive? It's like us trying to tune into smoke signals. Maybe they've got well beyond radio waves. Maybe they're using, as I interviewed Dan Wertheimer from Arecibo a few weeks ago, and he said they could be using faster than light particles to communicate. And I thought, oh wow. Or they could be using lasers. That's another way we could communicate with alien life. So this I see as being the new breakthrough in astronomy, the new way forward. And the big question is, are we alone in the universe? If we are, it's significant. If we aren't, it's equally significant.
And we hope that Pat will be invited back to Morley when the first signals are picked up from space, and we can tell you about the aliens, because that will be the next chapter in the history of astronomy. But talking about chapters, we just happen to have some books with us. This talk is based on the story of astronomy, our paperback, which covers everything you've heard, and obviously a lot more detail as well. If you prefer to be talked at by Heather, as we've all enjoyed this evening, this is an audio book. It's a 30-part series that Heather presented on BBC Radio 4. So there's 7.5 hours of Heather telling you about the history of astronomy. So the next time you've got a long journey, do tune into that. Rather than listen to radio, I'll show you. So these cover the history of astronomy we'll be talking about this evening. We've also got a couple of other titles with us. Want to do the next one? Yep.
Every year we publish a book called Stargazing, whatever. It's been published for 11 years now. This is a practical day, month-by-month guide to the night sky. Every month you get a star chart, tell you where the stars are, where the planets are, tell you interesting objects and things like that. And it's very much adored, and we are writing.
Just before we move on, we do have some spare copies of last year's, 2014. Obviously, that's going to be no help in looking around the sky, but we're going to give them away free if anybody wants to have a free book of what was up in the sky last year. And there are free pictures, I can tell you that.
And the latest book is coming out on Monday.
Pre-publication copies available.
Yes. And that's generally a very practical guide to the night sky. It tells you how to get involved in astronomy, be involved in schemes like how to do SETI at home, citizen science, where you can actually get involved in professional programs, practical guide to planets.
Detailed maps of all the constellations and everything in them.
Yeah, so that was exhausting to write. So these are the 4 books we have with us.
And in the meantime, we're very happy to answer any questions. I'm sure you're bursting with ideas you want to run past us. Thank you very much.
Thank you very much.